Hi all of you, welcome to another lecture of nanoelectronics. The topic for discussion today is resonant tunnel effect and resonant tunnel diode. Myself Maria Joseph, Assistant Professor in Electronics and Communication Department of MPC Pyramid, leading the session. Resonant tunnel devices. In this session, we'll study the resonant tunnel diode and later we will learn about the resonant tunnel transistors. We'll begin with the concept of tunneling. There is a non-zero probability of transmission of particles through a barrier with an insufficient energy to cross the carrier, and that particular phenomenon was called tunneling. We have seen it already. The maximum tunneling current produced for a specific voltage is called resonant tunneling current, and it is given by V1 is equal to 2 capital E by small e. We have learned all this. Now, this is the band diagram representing a double barrier. That is, E1 is the energy level in the well. Okay, consider a quantum well formed by a gas layer sandwiched by gas. Okay, two gas, a gas layer is sandwiched. Okay, the ground state energy of the well is given by E1. Fermi level EF is also shown in the figure. Then we have EC, which is the conduction band energy level. The tunneling current increases with applied voltage at the beginning. The current becomes maximum when the applied voltage matches the quantized energy E1 of the well. Or we can say that the current becomes maximum when energy of the carrier matches the discrete energy E1 of the well. We'll see that. Now, this is the IV characteristics of the double barrier, and this is the no transmittance at zero bias and maximum at V1. This is the figure that depicts the resonant tunnel effects. That is, the tunneling currents through the heterostructures can show zones of negative differential resistance. That is, NDR will be seen. The operation of NDR electronic devices is based on resonant tunnel effect. That is, the tunneling currents through the heterostructures can show zones of NDR, and the operation of the electronic devices is based on RTE. Resonant tunnel diode. What do you mean by a resonant tunnel diode? It consists of a quantum well formed in a double barrier structure with emitter and collector contact. This is the symbol of a RTD. RTD is a diode with a resonant tunneling structure in which electrons can tunnel through some of the resonant states at certain energy levels. Now the device structure is shown. With RTD, the source and drain contacts are separated from the channel region W by the tunneling elements. B1 and B2 in the figure represents the barriers. Okay, RTD can be fabricated mainly different types of materials such as 3,5 or 2,6 semiconductors. A diode with a resonant tunneling structure in which electrons can tunnel through some resonant states at certain energy levels. Within the RTD, the source and drain contacts are separated from the channel region by a width W, and the channel region can be described as a potential well. Now about the IV characteristics. That is, the region 1, energy of the incident electron does not match with the well energy E1, and hence the current is very small. At the peak 2, the energy level matches and the resonant current becomes maximum. At 3, due to the mismatch of electron energy, again the current reduces. Okay, all these things we have seen earlier itself. Advantages: no transit time limited, no minority carrier storage, better leakage current, easier to fabricate and design than tunnel diodes, multiple NDR peaks, and hence multi-value logic and memory can be realized. Thank you.